So now in this video we're going to take a quick look at the N-channel enhancement mode MOSFET. So all I really see them used as a switch, and that's what we're going to do here. There's also P-channel enhancement MOSFET, but we're using the 2N7000 N-channel enhancement mode MOSFET, and that's the pin layout for the TO92 package. Maybe there's other packages where it's different, but that's what I got, TO92. So be aware of that. Left pin is source, middle pin is gate, and right pin is drain. Source, gate, drain. When you put the component flat side to the right, then we got source, gate, drain, working our way up. The LED, make sure you put it in the right way. Short lead cathode towards negative, long lead anode towards positive. And we actually have the opposite setting from what I showed on the diagram there. We're to the negative supply and it is off. Now this is very susceptible, much more so than bipolar junction transistors, to stray signals. So I actually just made a short about that right before making this video, but that short's going to show up. It's already up when I made this video. This is going to come out like a week later, so don't look for a recent video if you're trying to find that short. So in any case, there we go. We're to the positive supply, and now the transistor is on. So we have positive supply to the gate. This is N-channel enhancement. So we need to make the channel more negative. We got the gate more positive, but it's kind of like a capacitor. So when you charge a capacitor, one side loses electrons, that's the positive side. The other side gains electrons, that's the more negative side right there. The component though, it's balanced because one side is a little less, the other side's a little bit more. It stays balanced all together, and you know, the little gap between the two helps hold that charge in balance. Not perfectly, that's why you can use it to power stuff. But in any case, we have that here. This can build up a charge and hold it, but when you get more electrons into the channel, it comes from other parts of the component, but it fills up with more electrons, and it starts conducting better if it's an N-channel enhancement MOSFET. That's what enhancement means. If it got worse, then it would be depletion. And they do make those as well, but all I have is N-channel enhancement, and that's generally all I see. So, and P-channel enhancement. So, in any case, we got the channel more negative, it's conducting, it's on. If we move the jumper to the negative supply, and that's probably turning on and off rapidly, like 60 times a second. But if we go to the negative supply, so now we switched it down here, and it's off. I wrote off on there to help make this easier. So again, it's N-channel enhancement. If we make the gate more negative, the channel gets more positive. Electrons are pushed out of it, and that cuts off its current. And so the LED is off right now. It comes to a dead end right there. This component is not conducting. And so it's really that simple. I see this used as a switch a lot. So I think that's pretty much how they're generally used. And I don't really see other circuits where they're used in a different way. So hopefully I come across them and can make videos, interesting videos of that. But for now, it's just a switch as far as I'm concerned. So thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help a lot. I'll see you in the next video.